When 6 fireballs hit the United States in 8 days, this channel asked a simple question: is Earth under siege? Most people didn't take that seriously. Then the deviation hit 4.5 sigma, and the American Meteor Society confirmed it, eliminated the obvious explanations and said out loud what scientists rarely say: something has changed up there, and we do not know what. That was March 25th. By March 28th, Fireball event number 11 crossed Washington state with over 100 witnesses, then Germany, then New Zealand. 3 continents, 1 month, no explanation. The background meteoroid environment doubled compared to every year on record. A comet is 3 days from the Sun. An interstellar object passed through 5 months ago, both pointing at the same region of sky. The camera that should have caught all of this was offline in Ohio. Stay with us. By the end, you will understand exactly what line just got crossed. If this has you hooked, subscribe to the Skylab and tell me what you think. After the fireballs, the sigma deviation, the global spread, the silent Ohio camera, and a scientific institution publicly admitting it does not know what changed, is Earth moving through something new, or are we simply at the wrong place on a very old orbit at a very interesting time? Let me know your thoughts. Now, let's get into it. Part 1. The moment the story broke. Something confirmed itself last week, and the confirmation made things worse. That is not how science is supposed to work. You identify an anomaly, you apply scrutiny. The anomaly shrinks under examination, or it gets explained, or it quietly fades back into the noise where it came from. That is the normal arc. That is what happened every other time someone thought the sky was behaving strangely. The data gets checked, the story gets smaller, everyone goes home. That is not what happened here. On March 25th, the American Meteor Society did something institutions rarely do with any kind of speed or drama. They confirmed it. They put out a statement acknowledging that the fireball activity over the United States during the first weeks of March 2026 was statistically anomalous. Not elevated, not worth monitoring, anomalous. They walked through every obvious explanation and eliminated them one by one, the way a methodical investigator crosses names off a list. Increased public reporting, checked and discounted. New meteor showers? No. Seasonal effects? No. Observational bias from new camera networks? No. They cleared the room, and when the room was clear, what remained was a sentence that should make the back of your neck feel strange. Quote, "Something has changed in the near-Earth meteoroid environment, and we don't know what." Read that again. A scientific body whose job is to track rocks falling out of the sky looked at their own data and said, publicly, that they do not know what is happening. Now here is the part where the normal arc completely collapsed. Within days of that confirmation, not weeks, not months, the anomaly did not stabilize. It did not normalize. It went global. A fireball was photographed over Brandenburg, Germany. Residential sky. Residential photograph. Clear enough to confirm. And not long after, a sighting report was filed with the AMS from New Zealand. New Zealand, Southern Hemisphere, approximately 9,000 miles from the region that everyone had been treating as the centre of this story. 3 continents, at minimum. Let that geometry sit for a second. When something strange happens in the American sky, you can construct a dozen reasonable explanations that are essentially geographic. Regional reporting infrastructure, population density, camera coverage, social media amplification, all of it concentrated in a specific corridor of the Northern Hemisphere. Those explanations are not exotic. They are the first thing any serious scientist reaches for, and every single one of them has one thing in common. They do not survive the New Zealand data point. You cannot explain a Southern Hemisphere fireball report as American observational bias. The planet does not work that way. And so this story crossed a line on or around March 30th. The line was geographic containment. As long as the anomaly stayed in one region, it could theoretically be local. Once it appeared in Brandenburg and Wellington on the heels of a scientific confirmation, the local anomaly explanation did not weaken. It died. The Brandenburg fireball is worth describing for a moment because it is not an abstract data entry. Somebody looked up at the German sky and saw something bright enough to photograph. That photograph exists. It shows what residential night sky photography of a fireball looks like. A streak, real and physical, burning through an atmosphere that belongs to the same planet, currently producing these events over Ohio, over Houston, over Washington State. The sky over Central Europe was part of this story, and the sky over New Zealand was too. Which forces a question that the American Meteor Society has not yet fully answered. If this is not a regional phenomenon, what kind of phenomenon is it? Here is where the scientific language gets interesting, because the AMS chose their words carefully. They said this is not cometary debris in the sense of a coherent debris stream, with a detectable radiant and an orbital path that intersects Earth on a predictable schedule. No new shower, no source point in the sky from which these fireballs are consistently radiating. That is the classic signature of a debris stream, and it is absent. But they also said, and this is the part that matters, they cannot rule out a disruption of the near-Earth meteoroid environment by a passing comet. Not caused by a comet, disrupted by one. That distinction is doing a lot of work, and we're going to spend time on it. What you need to hold on to right now is the shape of what just happened. A scientific anomaly was confirmed, and the confirmation did not contain the story. It exposed something larger. Because at the same moment the AMS was closing off American-centric explanations, the Anthelian zone, that region of the sky positioned directly opposite the Sun from Earth perspective, the place where diffuse background meteoroid activity is tracked as a kind of environmental baseline, was logging activity that had doubled compared to every prior year on record. Not spiked for a night, doubled, sustained, compared to every prior year on record. There is no radiant for that either, no identifiable stream, no new shower moving through that zone, just more material than there should be, coming from a direction that tells you something about the broader environment Earth is moving through, rather than any single point source. And that word, environment, is the one I want you to keep. Because what we are watching may not be an event. It may not be a meteor shower. It may not be a comet fragment or a debris trail or anything with a clean identifiable source. It may be something harder to categorize and harder to explain. A change in conditions. A shift in what Earth's near-space environment looks like as our planet moves through it. The anomaly did not fade after being confirmed. It spread. And the next question is not where the fireballs came from. The next question is what changed to make them possible everywhere at once. Part 2. The 4.5 sigma problem. Let's talk about what 4.5 sigma actually means in practical terms, because the number sounds technical, but the reality it describes is something anyone can understand. When scientists talk about sigma in the context of statistical significance, they are talking about how far a result sits from what you would normally expect. 1 sigma? Mildly unusual. 2 sigma? Noteworthy. 3 sigma? Scientists start paying attention seriously. 4 sigma? You are in the territory where, if you ran this experiment 1,000 times, you would expect to see a result this extreme maybe once. Maybe. 4.5 sigma sits in a zone where the probability of this being random noise is so vanishingly small that explaining it away as coincidence requires more creative thinking than explaining it as real. But here is the crucial thing about this particular 4.5 sigma result, and this is what separates it from a lot of statistical anomalies that turn out to be nothing. It is not in the total count. The total number of fireball reports going up could, under the right circumstances, be explained by improved infrastructure, more cameras, a more connected population more likely to report sightings. Annoying for scientists, but explainable. The deviation here is in the distribution, specifically in what statisticians call the high mass tail, the big end. The end where the heavy, energetic, atmosphere-penetrating objects live. Think of it this way. Imagine a bell curve representing the normal distribution of fireball events by size and energy. Most fireballs cluster in the middle. Modest size, modest brightness, doesn't travel particularly deep into the atmosphere. Maybe a few hundred people see it if it happens over a populated area. That is the bulk of the distribution. The tail on the high energy end is thin. It is supposed to be thin. Large, dense, fast-moving objects that can penetrate deep enough to generate sonic booms, actual physical pressure waves that rattle windows and shake buildings. Those are rare by the basic physics of what it takes for a rock to survive long enough in an atmosphere to do that. During this anomaly window, that tail doubled. Events with 50 or more witnesses, a threshold that indicates a bright, long-lasting, widely visible fireball, rather than a local sighting, doubled. Events with more than 100 witnesses doubled. and the sonic boom rate across all high-energy events climbed to 79%. That last number is important enough to repeat: 79%. Sonic booms are not a reporting artifact. You cannot explain a sonic boom by saying more people had their phones out. A sonic boom is a physical event. It means a physical object of sufficient mass and density moved through the atmosphere at sufficient speed and made it deep enough to compress air into a pressure wave that travelled across the ground. That is real. That is measurable. And when nearly 4 out of 5 high-energy fireball events during this period were associated with them, you are not looking at an observation bias. You're looking at evidence that physically larger, denser, more energetic objects were entering the atmosphere at an elevated rate. And that brings us directly back to the central question this story keeps forcing: what changed? Because this is not a reporting problem. This is a physical problem. Something was different about what was arriving. The objects themselves were different. More of the population during this window was on the massive end of the curve. Long-duration fireballs, events where the object spends enough time burning that it lights up the sky for an extended period, increased by roughly 2.5 times. Duration in the atmosphere is a proxy for size. A larger, denser object takes longer to ablate. It goes deeper. It generates more light for more time. It is harder to miss and harder to explain away. The American Meteor Society went through all of it. They did not want to confirm this. Confirming it means acknowledging that something is happening that they cannot explain, and institutions generally prefer to be in the business of explaining things, but the data left them no room. The AI-assisted reporting caveat, the idea that algorithmic social media amplification might be driving more reports to the AMS website, got examined and discarded. Partly because sonic booms cannot be socially amplified. Partly because the high mass tail shift would require not just more reports, but specifically and exclusively more reports about big sonic boom-producing long-duration events, with no corresponding increase in small events. That is not how reporting bias works. That is not how any artifact works. If you are seeing more reports because of better infrastructure, you see more everything. You do not selectively see more of the energetic outliers. So the 4.5 sigma result stands, and it stands not as a quirk of data collection, but as a description of physical reality. More energy was entering the atmosphere than historical baselines predicted, and we still do not know why. Part 3. Event 11 and the Failure of Containment. On March 28th, 3 days after the American Meteor Society confirmed the anomaly, a fireball crossed the sky over Washington state. 117 people reported it to the AMS, that made it by the criteria used to track high-witness events during this period, event number 11. 11 events with more than 100 witnesses, in a single month. The historical baseline for events of that scale runs at roughly 2 per month, sometimes 3 if the calendar cooperates with a known meteor shower. In this window, it was 11, and the 11th one arrived after the confirmation, after the scientific acknowledgement, after the elimination of every ordinary explanation. The Washington State fireball was travelling at approximately 39,000 miles per hour. That is not unusual for a meteoroid. They come in across a wide range of speeds, but it is energetic enough to produce a significant light event, and the geographic spread of the reports confirmed it. Witnesses from multiple counties, different viewing angles, all pointing at the same object crossing the same sky. The event itself was real. The 117 people who reported it were not confused. What makes it significant is not the event in isolation. It is the timing and the pattern. Think about what it means for the anomaly to continue producing outliers after being scientifically validated. There is a concept in complex systems analysis sometimes called containment failure, and it describes what happens when an anomaly does not respond the way a contained problem should. A contained problem, when identified, shows some response to the identification. The conditions stabilize, the rate of extreme events drops back toward baseline. The system, having been recognized as unusual, begins to normalize. That is the behavior of something that had a temporary identifiable cause. This did not do that. The system kept producing outliers. The statistical tail kept throwing large objects at the atmosphere. The geographic spread kept widening. Event 11 landed on March 28th. March 28th was not the end. Let's rewind slightly to build the full picture because the accumulation effect matters here. Before Washington State, there was Ohio, a major fireball in early March that became one of the original anchor events. There was the Houston event, a California sighting, a Michigan event that was visually striking enough to generate significant local attention. 6 events in 8 days was the headline that started this story. Then the count climbed to 7, then 9, then the AMS confirmation happened and it became 10. Then Washington State made it 11, and at that point something important had shifted in the nature of the data. Each individual event taken alone is explainable. Any given fireball has a source, a velocity, an orbit that brought it to this intersection with Earth's atmosphere on this particular night. Individual fireballs are not mysteries. The solar system is full of debris. Earth runs into it constantly. What is not explainable on an event-by-event basis is the compound pattern. The fact that the distribution kept producing extreme values. The fact that after 100 witness event, there was another and another, and that the system showed no sign of returning to the rate of roughly 2 per month that decades of observation had established as normal. The compound anomaly window, the idea that a period of time can itself become the anomaly, not just the individual events within it, is a framework that makes intuitive sense once you see the full accumulation. It is not that any single fireball was impossible. It is that 11 of them, with these characteristics, in this time frame, with this sonic boom rate, with this long duration profile, across this geographic range, simultaneously with the doubling of anthelion zone activity, constitutes a pattern that cannot be mapped onto any single known source. And this was all before the German photograph, before the New Zealand report, before the story left North America. Before it became obvious that whatever was happening over Ohio and Texas and Washington was also happening over Brandenburg. Even before it went global, the pattern had already broken every boundary we use to define normal fireball activity. The monthly threshold, the high witness threshold, the sonic boom rate, the long duration rate, the anthelion baseline, every single one of them exceeded simultaneously within the same calendar window. The system did not return to baseline. It kept producing outliers, and then it got bigger. Part 4. Europe wasn't an outlier. The Brandenburg fireball was not Europe's introduction to this story. That is the thing most English language coverage of this anomaly has been underplaying, and it matters enormously for understanding the actual scope of what we are looking at. Brandenburg was the image that circulated, the residential photograph, the moment Europe entered the visual narrative, the frame that made people outside the scientific community realize this had stopped being an American story. But Europe had been in the data for weeks before that photograph existed. The visual confirmation arrived late. The physical reality had been accumulating quietly, in tracking network databases and witness report logs, while the headlines were still pointing at Ohio and Texas and Washington State. Go back to March 8th. A bolide, a fireball bright enough and energetic enough to occupy a category above ordinary fireballs, a rare class of atmospheric event that sits at the top end of the brightness scale, crossed Western Europe. 3,229 people reported it to tracking networks. Pause on that number for a moment, because it is easy to let large numbers slide past without registering what they mean. 3,229 individual people, in different locations, looking at different angles of the same sky, all saw the same object and all thought it was significant enough to report. That is not a marginal event logged by a handful of dedicated observers with specialized equipment. That is a bolide that lit up the night over a populated continent. And it was energetic enough to survive. The meteorites were recovered. This was a physical object that entered the atmosphere at interplanetary velocity, ablated, decelerated, and landed on European ground where people subsequently went and picked up the pieces. That is not an observation. That is a sample. That is a chunk of the solar system sitting in a laboratory somewhere right now, waiting to tell us where it came from. The recovered material was identified as diogenite. If you are not already deep into meteoritics, the name probably means nothing to you, but it should, because it is going to become important later in this story, and the implications of it are strange enough to warrant a brief introduction now. Diogenites are a class of achondrite meteorites, rocks that did not form from primitive, undifferentiated material the way most meteorites do. They formed inside a body that had gone through the process of planetary differentiation, a body that had a magma ocean, a body that developed layered internal structure, core, mantle, crust, the way Earth did, the way Mars did, the way the rocky planets of this solar system did when they were young and molten and organising themselves under gravity. The leading source hypothesis for diogenites traces them to the asteroid 4 Vesta, one of the largest objects in the main belt, or to the family of smaller bodies that share Vesta's compositional heritage through past collisions. They are not common. They represent a small fraction of the meteorite population. Finding one is unusual in any year. Finding one in the middle of a sustained fireball anomaly window during a month that was already producing statistical deviations at the 4.5 sigma level is the kind of thing that deserves more than a raised eyebrow. We will come back to it, but hold on to it. 3 days after the Western Europe bolide on March 11th, France and Spain saw another event. 236 reports. A different object, a different trajectory, a different entry corridor through the atmosphere, but the same calendar window. 2 significant European fireball events in 3 days, both sitting inside the same March 2026 period that was simultaneously producing event after event over American airspace. 2 continents, 1 month, no shared radiant, no connecting stream. Here is the thing that the geographic spread forces you to confront, and it is the kind of confrontation that quietly dismantles several comfortable assumptions at once. The European events were not after the American events. They were not downstream of the American story in any causal or temporal sense. They were concurrent, running in parallel. The timeline, when you lay it out flat and stop organising it by continent and start organising it simply by date, shows American events and European events interleaved within the same weeks, arriving from different directions, crossing different skies, generating different witness populations, but clustering in the same narrow calendar window with no geographic logic connecting them. There is no east to west progression, no north to south sweep, no temporal structure that would suggest Earth was moving through a localised field in a particular direction, and the European events were simply the leading or trailing edge of that passage. This matters because the most intuitive mental model for a surge in fireball activity is a stream, a filament of debris, a cloud of material with a spatial origin that Earth is moving through in a particular direction, the way a car drives through a region of heavy rain. And if that mental model were correct, you would expect a temporal structure to the events. The leading edge of the planet hits the debris first. The trailing edge hits it later, or misses it entirely. The events cluster geographically in ways that correspond to where Earth's orbital motion is carrying it at that moment. There is a front, there is a back, there is a direction. There is no direction here. The brightness profiles across European and American events are consistent with each other in ways that matter scientifically. Duration patterns match. The proportion of deep penetrating, sonic boom-producing, high-energy events in the European dataset mirrors the proportion in the American dataset. The same signature that characterized the American anomaly, high energy, wide visibility, long duration, was showing up in European skies simultaneously and independently. Different objects, different trajectories, same profile. That consistency is not easy to explain away, and it is worth sitting with the reason why. If these were 2 genuinely independent spikes in 2 separate regions driven by separate local causes, you would expect some divergence in the characteristics. Different local debris populations would have different size distributions, different velocity profiles, different entry angles. The events would share a time window, but not necessarily a physical signature. What the data shows instead is something that looks less like 2 separate anomalies that happen to occur at the same time, and more like one anomaly expressing itself simultaneously across a planet. One environmental condition affecting Earth's entire sphere, not a regional pocket of unusual activity that happened to be overpopulated Europe on one night and populated America on another. And if one anomaly is expressing itself across a planet, you are no longer in the territory of a local debris field or a regional reporting surge or any explanation that relies on geography. You are in the territory of a shared environment. Something that Earth's entire surface is moving through simultaneously, not just the hemisphere that happens to be facing a particular direction at a particular hour. The AMS's open question, what changed in the near-Earth meteoroid environment, just became geographically enormous. Whatever the answer is, it has to be big enough to account for events in Washington State and Brandenburg and the Western European bolide corridor, all within the same month. It has to operate at a scale where the distinction between the American side of the planet and the European side is essentially irrelevant to the physics. That is a significant constraint on the possible explanations. A localized debris stream cannot do that. A regional reporting surge cannot do that. A new meteor shower associated with a single parent body on a single orbital path cannot produce simultaneous high-energy events across hemispheres with no shared radiant and no temporal structure. The explanation, whatever it turns out to be, has to be environmental in the broadest sense. It has to describe a condition that Earth is inside rather than a source that Earth is passing by. There is a word that keeps appearing in the scientific language around this anomaly, and it is worth highlighting because it represents a genuine shift in how the problem is being framed. The word is environment, not stream, not shower, not source, environment. The AMS did not say a new object is producing fireballs. They said the near-Earth meteoroid environment has changed. That framing is deliberate. It is the framing of scientists who looked at the geographic distribution, the absence of a radiant, the simultaneous multi-continental expression of the same physical signature, and concluded that the problem is not localized. The problem is the medium Earth is moving through. Europe was not a new development in this story. Europe was confirmation that the story was always bigger than the American data suggested. The Brandenburg photograph gave it a face. The March 8th bolide gave it a sample. The France and Spain event gave it temporal density. And together, they gave the anomaly something it did not have when it was still being treated as a North American curiosity. They gave it planetary scale. We had not discovered a new region of activity. We had discovered the same activity happening everywhere. And the question that raises, not what is falling, but what Earth is moving through that is making it fall everywhere at once, is the question that the rest of this story is built around. Part 5. The Southern Hemisphere Break. New Zealand changed the geometry of this story in a way that cannot be undone, and geometry in this context is not a metaphor. It is the literal physical reason why a single sighting report from the Southern Hemisphere carries more scientific weight than a dozen additional reports from the Northern Corridor where this story began. Geometry is what determines which hemisphere a falling object strikes. Geometry is what connects orbital trajectories to impact distributions, and geometry is precisely what the New Zealand data point broke, cleanly, irreversibly, and with implications that reach all the way back to the first Ohio fireball and forward to every explanation that has been offered for what is happening. Before March 30th you could, with some effort and intellectual flexibility, construct a Northern Hemisphere narrative. It required work, but it was not unreasonable work. Most of the world's fireball tracking infrastructure sits in the Northern Hemisphere. Most of the reporting networks, most of the dedicated camera arrays, most of the citizen science population equipped with smartphones and apps linked to the American Meteor Society, all of it concentrated above the equator, in the populated latitudes where wealthy, connected societies have had the resources and the interest to build observation capacity over decades. Europe and North America together represent a genuinely massive concentration of detection ability. The rest of the planet, in terms of systematic fireball tracking, is comparatively sparse, and sparse coverage produces a specific kind of distortion. It makes things that happen in covered regions look more significant than things that happen in uncovered ones, simply because the covered regions are the ones generating data. So the argument was available. The surge is real, you could say, but it is regionally contained. The apparent global spread is not global activity. It is the visibility advantage of being located where the observation networks are densest. Germany has cameras and a connected public. The United States has the AMS and a population that reports things. The events are clustering in the data because the data collection is clustering geographically, not because the events themselves are. It is a legitimate methodological argument. Scientists make versions of it routinely when interpreting uneven datasets, and until March 30th, it had not been definitively closed. The New Zealand report closed it. New Zealand sits at approximately 41 to 46 degrees south latitude, depending on which part of the country you're standing in. It is in a different hemisphere entirely, operating under a completely different sky, connected to no shared northern observation network, and experiencing a different season. March is approaching autumn in New Zealand, not spring, which removes any possibility of a shared seasonal explanation connecting it to the northern events. A fireball observed from Wellington is not the same event as a fireball observed from Seattle. It is not a distant view of something that also lit up the American Northwest. It is not a duplicate entry generated by a reporting network that spans both sides of the equator. It is a separate physical object on a separate trajectory, entering the atmosphere over a separate part of the planet that happens to be 9,000 miles from the region where this story started. You cannot explain that with Northern Hemisphere observational bias. The Southern Hemisphere is not a reporting artifact of the Northern Hemisphere. The planet does not work that way. What the New Zealand report does, scientifically, is remove hemispheric bias as an escape route, and hemispheric bias is worth understanding properly because it has been one of the more durable methodological caveats available to skeptics of the global framing. The geometry of Earth's orbital motion, the tilt of the ecliptic relative to the equator, and the historical concentration of observation infrastructure in populated northern latitudes have always contributed to a fireball dataset that skews north. Scientists know this. They account for it in their models. It is not a flaw in the science. It is an honest acknowledgement of the limitations of the observation network. And as a caveat, it has real and legitimate force, until it encounters synchronized Southern Hemisphere activity. At that point, it stops being a caveat and starts being a disqualified escape route. Think carefully about what synchronized activity across hemispheres requires from the underlying physics, because this is where the geometry becomes genuinely constraining. Objects entering Earth's atmosphere arrive from specific directions determined by their orbital paths. A localized debris stream, a filament of material shed by a comet, a trail of fragments from a disrupted asteroid has a geometry. It occupies a region of space with a direction. Objects from that stream preferentially strike whichever part of Earth is geometrically facing that direction at any given time. The Northern Hemisphere gets hit when it's facing the stream. The Southern Hemisphere gets hit when it's facing the stream. Both hemispheres do not get hit simultaneously from a localized stream, because a localized stream does not surround the planet, it approaches it from one direction. For both hemispheres to show elevated activity within the same narrow time window, one of two things must be true. Either the source has an angular distribution wide enough to intercept Earth from multiple directions at once, which is not a stream, that is a field, or the enhancement in the background meteoroid population is dense enough that the entire sphere is encountering elevated material simultaneously, regardless of which direction any given part of the surface is facing at any given moment. The material is not approaching Earth from an angle, it is around Earth. Earth is inside it. Either way, you're not talking about a stream. You're talking about something more like a condition, an environmental change, the conceptual equivalent of Earth moving through a region of space where the density of material is simply higher than it was before, higher in every direction, higher for every part of the surface, higher in a way that expresses itself as elevated fireball rates whether you're standing in Washington State or Wellington. There is a natural zone in the sky that produces exactly this kind of wide hemispheric distribution over time, and we are going to spend considerable time on it in the next section. The Anthelian region sits at a point in the sky that corresponds by basic orbital geometry to material with a diversity of inclinations and eccentricities wide enough to intercept Earth from a range of directions rather than a single concentrated corridor. As Earth orbits the Sun, the Anthelian point moves with it, sweeping through the sky over the course of a year. A material concentrated in that background zone encounters the planet in ways that do not naturally favour one hemisphere over the other in any given month. It is the part of the meteoroid environment that is most likely to produce symmetric global activity that does not care which side of the equator you are on. But here is the tension that the New Zealand event sharpens rather than resolves, and it is important to hold both sides of it clearly. The Anthelian activity doubling, the sustained record-level amplification of background meteoroid flux in that region of the sky, is a slow phenomenon. It is measured over weeks and months. It represents a shift in the baseline, the statistical floor of what Earth encounters as it orbits. The individual fireball events over Germany and New Zealand and Washington State are not slow. They are discrete, they are dramatic, they are high-energy arrivals that happened on specific nights and generated specific witness reports, and, in at least one case, left physical material on the ground. The relationship between the background shift and the specific high-energy events is not straightforward. The data shows both happening simultaneously, The data does not show, with clarity, that one caused the other. They may share a common upstream cause. They may be two expressions of the same environmental change operating at different scales. Or the temporal overlap may be telling us something about a causal chain that the current dataset cannot yet resolve. What the data does show is this: something about the environment has changed, and that change is expressing itself on every part of the planet's surface that we have the infrastructure to observe. And that last clause is the one that should make you uncomfortable, because the infrastructure is not global. The southern hemisphere has always been underrepresented in fireball tracking. The ocean coverage is minimal. The rural interior coverage of the southern continents is sparse. New Zealand has some observation capacity. Much of the southern Pacific, the southern Atlantic, the interior of southern Africa and South America, essentially nothing. If New Zealand is reporting elevated activity during a month when even its sparse tracking networks are catching something, what is happening over the parts of the southern hemisphere that have no tracking networks at all? The anomaly is larger than our observation network. We are reconstructing a global phenomenon through instruments that cover perhaps 40% of the planet's sky with any real density. The other 60% is largely silent, not because nothing is happening there, but because we are not listening. That silence is not reassuring. It is a data gap wearing the costume of calm. This is not where we are looking. This is what Earth is moving through. And what Earth is moving through appears to be bigger, more symmetric and more global than any Northern Hemisphere narrative was ever going to be able to contain. Part 6. The Anthelion signal doubled. There is a region of the sky that most people have never heard of, and it has been keeping a secret. Not a dramatic secret. Not the kind that announces itself with a bright streak across the night, or a sonic boom rattling windows at 2 a.m. A quiet secret. The kind that accumulates slowly in databases and baseline measurements, and decades of careful observation, invisible until the moment the numbers stop matching what they are supposed to say. That is the kind of secret the Anthelion source has been keeping. And in March 2026 the numbers stopped matching. To understand why that matters, you need to understand what the Anthelion source actually is, because it is one of those concepts that sounds technical until you grasp the underlying geometry, at which point it becomes almost elegantly simple. The Anthelion source is not a meteor shower in the way that the Perseids or the Leonids are meteor showers. Those are named streams, coherent structured trails of material shed by specific comets or asteroids over repeated solar passages, occupying a relatively narrow orbital corridor that Earth's path intersects at a predictable time each year. The Perseids arrive in August because Earth crosses the debris trail of Comet Swift-Tuttle in August. Every August. You can set your calendar. You can tell your kids to stay up late because there will be something worth seeing, and you will be right, and you will have known you would be right weeks in advance. Named meteor showers are the scheduled trains of the meteoroid world. They run on timetables. The Anthelion source does not run on a timetable. It is something older and more diffuse, and in some ways more fundamental. It is a background population of sporadic meteoroids, material with no single parent body, no identifiable origin stream, no named source, that concentrates in the region of the sky positioned directly opposite the Sun from Earth's current location. As Earth moves around the Sun over the course of a year, the Anthelion point moves with it, always sitting on the ecliptic plane, always pointing back along the direction of Earth's own motion through the solar system. It is in a sense the view from Earth's rear window, the direction from which Earth came projected onto the sky. The reason material concentrates in that direction is orbital geometry, and it is worth spending a moment on the mechanics because they explain why the Anthelion zone is such a sensitive indicator of the broader meteoroid environment. Objects in the inner solar system that have been scattered into a variety of orbital inclinations and eccentricities over millions of years of gravitational interactions, nudged by Jupiter, perturbed by Mars, slowly reshaped by solar radiation pressure in a process called the Yarkovsky effect, tend, in terms of where their orbits intersect Earth's path, to cluster in that anti-solar region of the sky. Not exclusively. The Anthelion source is not a wall or a barrier. Sporadic meteoroids arrive from all directions. But the Anthelion zone shows a measurable concentration, a statistical elevation above the isotropic background that reflects the aggregate orbital history of the inner solar system's small body population. It is the fingerprint of billions of years of gravitational sculpting, expressed as a mild but consistent enhancement in meteor rates from one particular region of the sky. Scientists have been measuring that enhancement for decades. They know what normal looks like. They have baselines stretching back through years of systematic observation, enough data to characterize the seasonal variation, the year-to-year fluctuation, the range within which the anthelian source can move without signaling anything unusual. That baseline exists precisely so that departures from it can be recognized and quantified. And in March 2026, the departure was not subtle. Normal had doubled. Not spiked for a single night in a way that might reflect a brief, localized enhancement from a small clump of material. Not elevated above baseline for a narrow window of days that could be attributed to Earth passing through a thin filament of debris on a specific orbital path. Doubled, sustained, compared to every prior year on record across the entire observational baseline. The anthelian source, the background radiation of Earth's meteoroid environment, the slow and ancient drumbeat of material that has been accumulating in those orbital corridors since before the continents reached their current positions, was producing twice as much observable activity as it ever had in the period of modern scientific measurement. Take a moment with that, because it is easy to let it slide past in the middle of a story, full of large numbers and dramatic events. Individual fireballs are exciting, sigma deviations are attention-grabbing. But a doubling of the background is something different in kind, not just in degree. When a dramatic fireball crosses the sky over a populated city, you can construct an explanation that is essentially local and specific. A particular object on a particular trajectory arrived at Earth's atmosphere on a particular night. The object had an origin. It had a history. The encounter was unusual, but in principle, traceable. You can imagine pointing at it and saying, "There, that thing, that is what happened." When the background doubles, you cannot point at anything. There is no single object to identify. There is no specific trajectory to reconstruct. There is no particular night that caused it. A background shift means the environment has changed, that the density of material in the region of orbital space Earth regularly samples as it moves through the solar system is higher than the observational record has ever shown it to be. The cause is not an event. The cause is a condition, and conditions are harder to trace, harder to explain, and in many ways harder to accept than events, because they do not have a clean origin story you can tell. So what changes a background? What process operates on the anthelian zone's diffuse, ancient population of scattered material and produces a measurable doubling on a timescale of weeks to months? This is where the science shifts from careful measurement into genuine uncertainty, and it is worth being honest about the texture of that uncertainty. It is not the comfortable uncertainty of a problem that is almost solved. It is the uncomfortable uncertainty of a problem where the available hypotheses each explain part of the picture, but none of them explains all of it. The first broad category of explanation is recent disruption. Something broke. A parent body, an asteroid, a comet nucleus, a large rubble pile object in an appropriate orbital zone experienced a fragmentation event at some point in the recent past, geologically recent meaning years to decades rather than millions of years, and the resulting debris has been evolving orbitally ever since, gradually dispersing into the corridors that feed the anthelian background. Fresh material introduced on a short time scale could, in principle, produce a measurable enhancement before it had time to spread thin across the full population. This explanation has genuine appeal. Asteroid fragmentation events happen, comets break apart. The solar system is not static, and disruption events that go unobserved are not exotic. Most of the sky goes unwatched most of the time. But a disruption energetic enough and recent enough to double the anthelian background should, in principle, leave traces. The resulting fragments should carry a shared compositional signature. Their cosmic ray exposure ages, the clock that starts when a fragment is exposed to galactic cosmic radiation after being separated from its parent, should cluster around the disruption event. The material arriving at Earth should show some coherence in its orbital parameters, some residual directionality from a common origin, even after years of dispersal. And that coherence would express itself as at least a partial radiant, a concentration in the sky from which the material disproportionately arrives. There is no such concentration. The absence of a coherent radiant suggests the material is arriving from too many different directions to share a single recent parent. which either means the disruption happened long enough ago that dispersal has erased the directional signal, or means the source is not a single disruption at all. The second category is external perturbation. Something gravitationally massive moved through the inner solar system recently enough, and closely enough, to have altered the orbital distribution of material that was already present, reshaping orbits that were previously stable into orbits that now intersect Earth's path at elevated rates. The material was always there, the orbits changed, and the agent of that change was not an internal solar system process but an external visitor, a comet. An unusually large object on an unusual trajectory, something whose gravitational influence was sufficient to act as a redistributor of existing debris on a timescale short enough to produce observable effects within months. The comet currently 3 days from perihelion is not confirmed as that agent. The link has not been established. But the mechanism is physically coherent, and the timing is specific enough that dismissing it requires an active choice rather than a passive default. The Anthelian signal does not point at either explanation. It does not point at anything. There is no radiant, there is no source, there is only a condition, measured, quantified, statistically robust and unexplained. A doubling of the background activity in a zone that has been stable across the entire modern observational record. Conditions do not arise from nothing, they arise from causes, and the cause of this one has not been found. If the background changed, something changed it. That question is still open, and the longer it stays open, the more interesting the answer is going to be. Part 7. The Not Cometary Paradox. The official scientific position on this anomaly contains a contradiction, and the scientists know it. That is not a criticism. It is actually a sign that the science is being done honestly. Contradictions in official positions usually mean one of two things. Either someone is being careless, or the phenomenon being described is genuinely complex enough that a single clean statement cannot contain it. In this case, it is the second one. The American Meteor Society arrived at a position that sounds contradictory because the anomaly itself is contradictory, because the data is pointing in two directions simultaneously, and the intellectually honest response to two simultaneous contradictory signals is not to pick one and ignore the other. It is to hold both, label the tension clearly, and wait for the evidence that resolves it. That is what they did. And the tension they are holding is more interesting than either statement alone. Here is what they said, stripped to its essential structure. This is not cometary debris, and we cannot rule out a disruption of the near-Earth meteoroid environment by a passing comet. Read those two sentences slowly, because the gap between them is where the entire mystery lives. The first sentence says the source is not a comet. The second sentence says a comet may have caused the source to change. One sentence is about origin, the other is about mechanism, and the reason they do not cancel each other out, the reason both can be true simultaneously, is that origin and mechanism are not the same thing, and conflating them is precisely the error that makes this anomaly hard to think about clearly. When scientists say the fireball surge is not cometary debris, they are making a specific technical claim about the physical profile of the material entering Earth's atmosphere. A comet debris stream has a signature, and it is a recognizable one. It has a radiant, a point in the sky from which the meteors appear to originate, produced by the geometric perspective of parallel travelling objects converging toward the same vanishing point, the way parallel train tracks appear to meet at the horizon. That radiant is not optional. It is a geometric inevitability for any coherent stream of material travelling on similar orbital paths. It has a velocity distribution that reflects the orbital parameters of the parent comet. The speed tells you something about where the object came from and how it is moving. It has a compositional profile reflecting the comet's own material, which tends to be dusty, volatile rich, fragile, the kind of stuff that produces brilliant light shows at high altitude, but rarely survives long enough to generate sonic booms or reach the ground in recoverable form. Cometary meteor showers are typically characterized by fast, bright, shallow events, beautiful but brief. The material burns high and leaves nothing behind. That profile is absent from this anomaly, completely and specifically absent. There is no radiant. Scientists have looked for one and found nothing. No concentration in the sky from which the fireballs are preferentially arriving. No geometric signature of a coherent population on similar orbits. The velocity distribution does not match what you would expect from cometary ejecta. The sonic boom rate is 79%, which means the material is dense and rocky and penetrating deep into the atmosphere, not the behaviour of fragile cometary dust. Meteorites have been recovered. Physical, solid, ground-landing fragments of the incoming material are sitting in laboratories right now. Cometary meteor showers do not produce recoverable meteorites. The material is simply not the right kind. Whatever is falling is rocky, dense, and arriving from multiple directions with no coherent source signature. It is not a comet stream. That conclusion is solid. And yet, a comet does not have to shed its own material onto Earth to change what falls on Earth. This is the distinction that is doing enormous amounts of work in the AMS position, and it is subtle enough that it is worth unpacking carefully, because it is the conceptual key to the entire paradox. A massive comet moving through the inner solar system is not just a light source and a spectacle. It is a gravitational event. It has mass. It follows an orbital trajectory that carries it through regions of space populated by asteroids, meteoroids, and small bodies that have been settled into relatively stable orbital paths over long periods of time, paths shaped by billions of years of planetary interaction, slowly sculptured by the gravitational dominance of Jupiter and the persistent subtle pressure of solar radiation. Those settled paths are not rigid. They are dynamically stable under normal conditions, meaning they do not change dramatically on human timescales, but they are sensitive to perturbation. A sufficiently massive object passing through that region does not have to collide with anything. It just has to be close enough for long enough that its gravitational influence nudges the orbital parameters of nearby bodies in ways that accumulate. Think of it as the gravitational equivalent of walking through a room where every surface is covered with objects balanced at the edge of tipping. You do not have to touch anything. Your passage displaces air. The floor vibrates slightly under your weight. The subtle fluid dynamics of the room shift around you, and some fraction of the objects that were right at the balance point, the ones that needed only the smallest push, tip over, not because you knocked them, because your presence in the room changed the conditions enough that the marginal case is resolved. A comet passing through the inner solar system does this gravitationally. Objects that were on orbits just barely not crossing Earth's path get nudged. Their perihelion shifts slightly. Their inclination changes by a fraction of a degree. Their eccentricity evolves. None of these changes are dramatic individually. Collectively, over months or years of orbital evolution following the perturbation, a fraction of them migrate into Earth-crossing configurations. They are not the comet's material. They were always there. They are just in different places now, places that happen to intersect Earth's orbit at the current moment in a way they did not before. The comet approaching perihelion on April 4th, catalogued as C/2026 A1, carrying the provisional designation MAPS, is on track to pass approximately 50,000 kilometers above the solar surface. That number requires context to appreciate properly. The Sun's radius is roughly 696,000 kilometers. 50,000 kilometers above the surface means this comet is passing at a distance from the center of the Sun of approximately 746,000 kilometers, less than 1.5 solar radii from the center of a star. That is a sun-grazer approach. Objects that make passes this close to the Sun are in a category of their own in terms of the gravitational and thermal forces they experience. The Sun's gravitational field at that distance is intense. The tidal forces are significant. The comet itself may shed material, may partially fragment, may be dramatically altered by the encounter. And if this comet has made prior passes through the inner solar system, if its orbital history includes previous perihelion passages that carried it through the asteroid belt and the inner planet region, then those previous passages already did gravitational work that we are only now measuring in the form of altered meteoroid orbits and elevated fireball rates. This is the mechanism the AMS is leaving the door open for, not the comet as a source of the material. The comet as a gravitational actor that rearranged existing material into configurations that are now producing the anomaly. The fireballs are not pieces of the comet. They are pieces of the solar system that the comet moved, possibly years ago, possibly on a prior orbital pass that nobody was tracking with sufficient precision to anticipate these consequences, and whose long, slow orbital evolution since that perturbation has finally, in March 2026, brought them into Earth-crossing alignment. This is not confirmed. That point deserves its own sentence because it is important and it is easy to lose in the momentum of a compelling mechanism. The American Meteor Society has not established a causal chain between C/2026A1 and the fireball anomaly. No scientific body has. The plausibility of the mechanism is real, the physics are coherent, the timescale is not impossible, the orbital geometry is consistent, but plausibility is not confirmation. A mechanism that could explain the data is not the same as a mechanism that has been shown to explain the data. The distinction matters, and maintaining it is the difference between following the evidence and telling a good story. What has been established is the shape of the problem. The anomaly is not a comet stream. The anomaly may have been caused, at least in part, by a comet's gravitational influence on existing material. Both statements can be true. Neither resolves the open question of what specifically changed, when, and whether the change is ongoing or already fading. Science has gotten quite good at eliminating options. What it has not yet done is fill the space those eliminated options left behind. The profile of the anomaly is clear, the cause of the anomaly is not. And every time the investigation narrows the problem from one direction, the problem reveals new dimensions from another. We can describe what it is not with considerable precision. We cannot yet describe what it is. And that gap between a well-characterized phenomenon and an unidentified cause is where this story currently lives. It is not a comfortable place, but it is an honest one. And the answer, when it comes, is going to have to be big enough to fill it completely. Part 8. The objects themselves are wrong. Everything discussed so far has been about quantity. More events, more witnesses, more energy, more geographic spread. The numbers have been the story, the sigma deviation, the doubled background, the 1100 witness events in a single month, the 3 continents, the sonic boom rate climbing to 79%. Quantity has been doing most of the narrative work, and it has been doing it well because the quantity alone is strange enough to justify serious attention. But there is a dimension of this anomaly that quantity alone does not capture, a dimension that, once you see it, reframes everything that came before it, not as context for a surge in numbers, but as evidence of something more fundamental, a change not just in how much is arriving, but in what is arriving, in the physical character of the objects themselves, in the orbital signatures they carry and the compositional stories they tell, and the geometric impossibilities they collectively represent. The objects themselves are wrong. Not wrong in the sense of being physically impossible or violating any known law of planetary science. The solar system produces strange things. Individual anomalous objects arrive all the time, and individual anomalous arrivals are by definition expected at some rate. Wrong in the sense that the characteristics of the fireball population during this window do not match what the known meteoroid environment is supposed to look like when you measure it systematically over time. The profile has shifted, the distribution has changed shape, and the specific ways it has changed are not random deviations from the norm, they are structured departures that point, however obliquely, towards something upstream that we have not yet identified. Start with orbital inclination, because it is the most diagnostic of the anomalies and the one that connects most directly to the question of where this material came from. Every meteoroid travelling through the solar system has an orbit, and that orbit has an inclination, an angle that describes how steeply it is tilted relative to the ecliptic plane, the flat disk of the solar system where the planets and the vast majority of the solar system's mass are concentrated. Most of the material in the inner solar system has relatively modest inclinations. It accumulated over billions of years in or near that plane, shaped by the gravitational dominance of Jupiter, pulling everything toward the ecliptic over long timescales, and by the slow, persistent influence of repeated planetary interactions smoothing out the extremes. The result is a population that is statistically fairly flat. Low inclinations are common. High inclinations, steep orbits that approach Earth from well above or below the ecliptic, arriving almost vertically rather than sweeping in from the side, are rarer. Not absent, but genuinely rarer. The solar system's orbital dynamics select against them over time. During this anomaly window, events with radiance at declinations above positive 70 degrees, which is the observational signature of very high orbital inclinations, objects arriving from nearly overhead, rather than from the low-angle directions that dominate normal fireball populations, doubled compared to historical records. Doubled. The rare end of the inclination distribution, the steep arrivals that the solar system's gravitational dynamics are supposed to suppress over billions of years of orbital evolution, was producing twice as many events as the baseline predicts. This is not a subtle statistical nudge. It is a structural shift in the population. And high orbital inclinations carry information, because the processes that produce them are not the same as the processes that produce low inclination orbits. Objects with steep orbits relative to the ecliptic typically got that way through dynamical processes more energetic than the gentle long-term averaging that produces the flat inner belt population. They were scattered. They were perturbed. They came from orbital regimes where gravitational interactions are stronger and less predictable, the outer solar system, the scattered disk, the regions where Jupiter's influence is less smoothing and more disruptive. Or they were kicked into high inclinations relatively recently by a close encounter with a massive object whose gravitational influence was sufficient to dramatically alter their orbital parameters on a short timescale. That last possibility connects directly to the mechanism the AMS left open when they declined to rule out a cometary gravitational perturbation. A comet massive enough and close enough to the inner solar system could preferentially scatter existing material into higher inclinations, not evenly across the population, but disproportionately affecting objects already in marginally stable orbits, pushing the ones nearest the edge of the inclination distribution over into configurations that are steeper, more eccentric, and more likely to produce Earth-crossing trajectories at high angles. The doubled high inclination rate is exactly what you might expect to see in the aftermath of that kind of perturbation, expressed in the fireball data as a population that is skewed toward the steep end in ways it should not be. And then there are the two HED meteorite falls, and this is where the story stops being about orbital mechanics and starts being about the specific physical history of specific pieces of the solar system. HED stands for howardite, eucrit, and diogenite, three related classes of a chondrite meteorite that share a compositional origin deep inside a differentiated planetary body. The diogenite recovered from the March 8th Western European bolide was one member of this group. A second HED fall, a separate event, a separate recovery location, a separate atmospheric trajectory occurred within the same anomaly window. Two HED meteorites from a rare compositional class falling within the same narrow calendar month. To understand why this matters, you need to understand what these rocks are and where they came from. HED meteorites are not primitive material. They are not the undifferentiated chondritic stuff that makes up the bulk of the meteorite population. The ancient, undisrupted material that has been floating around the solar system since before the planets formed, chemically unchanged, telling a story of the early solar system's raw ingredients. HED meteorites tell a different story. They formed inside a body that went through planetary differentiation. A body large enough and hot enough that its interior melted, that heavier elements sank toward the center under gravity while lighter ones rose, that developed a layered internal structure, iron-nickel core, silicate mantle, basaltic crust, the way Earth did, the way Mars did, the way the rocky planets of the inner solar system did during the first tens of millions of years after formation. The leading candidate for the parent body of HED meteorites is the asteroid 4 Vesta, one of the largest objects in the main asteroid belt, a body so large that it preserved the internal structure of a small planet even after the disruption events that scattered its fragments across the solar system. Pieces of Vesta, or of Vesta family bodies, are arriving at Earth, 2 of them, in 1 month. During a sustained anomaly window that is already producing doubled background activity, doubled high inclination events, a global fireball distribution, and a statistical deviation at 4.5 sigma. The rarity of HED falls in any given year makes 2 in a single month notable under any circumstances. In this context, the word notable feels insufficient. But here is the detail that transforms notable into genuinely strange, and it is a geometric fact rather than a statistical one. The 2 HED events had an angular separation of approximately 98 degrees. The points in the sky from which they appeared to originate, their apparent radiance, the directions from which they arrived, were separated by roughly 98 degrees of arc. That is almost a quarter of the entire celestial sphere. For 2 fragments that share a compositional origin in the same parent body, that angular separation is far too large to be explained by a coherent debris trail. A debris trail, the kind produced when a parent body fragments, and the resulting pieces evolve along similar but slightly diverging orbits, concentrates in a relatively narrow corridor of orbital space. The angular spread of radiance from a coherent trail might be a few degrees, maybe tens of degrees for an old well-dispersed stream. 98 degrees is not a dispersed stream. 98 degrees is two objects that share a distant compositional ancestor, but have been travelling on completely independent orbital paths, shaped by completely different dynamical histories, for a very long time. They did not arrive together because they left together recently. They arrived together because something, some process or perturbation or cascade of orbital evolution, converged them on Earth-crossing trajectories at the same moment despite their different histories. Two rare compositional types, same narrow time window, angular separation geometrically inconsistent with a common recent source. Arriving against a backdrop of doubled background activity, doubled high inclination events, and a global fireball distribution that has no identified cause. Each of these facts, taken individually, can be filed under unusual and set aside. Together, stacked inside the same calendar month, they form a pattern that resists that kind of compartmentalization. The statistical language that describes independent rare events clustering stops sounding like fluctuation and starts sounding like cause. Something upstream connected these arrivals, even if the connection runs through orbital histories too long and too complex to trace directly from the current data. The objects are not just more frequent, they are different in ways that carry information about where they came from and how they got here. The composition shifted, the inclination distribution shifted, the angular geometry of the rare events is inconsistent with simple explanations. And every one of those shifts points back toward the same unresolved question, the one the AMS confirmed and could not answer, the one the global expansion amplified, the one the Anthelion doubling embedded in the background of the entire solar system's observable behaviour. Something changed the population of what is arriving at Earth. The change is measurable across multiple independent parameters simultaneously. And simultaneous shifts across multiple independent parameters in a complex system do not typically arise from nothing. They arise from a common upstream cause that has not yet been identified. The pattern complexity of this anomaly has now exceeded what any single explanation can contain. Whatever the answer is, it is going to have to be large enough to account for all of it at once, and we are not there yet. Part 9. The timing. Nobody can ignore. Science is deeply uncomfortable with coincidence as an argument. It should be. The history of bad science is not a history of malicious actors or deliberate fraud, though those exist too. It is mostly a history of intelligent, well-meaning people who looked at patterns and trusted them before the patterns had earned that trust. Correlations that dissolved under scrutiny, clusters that turned out to be noise, timing alignments that felt cosmically significant until the dataset got larger and the signal disappeared into the background. The human brain is, at a fundamental neurological level, a pattern recognition engine that was optimized over millions of years for survival in an environment where false positives were cheap and false negatives could be fatal. Seeing a predator that was not there cost you a moment of fear. Not seeing a predator that was there cost you everything. So the brain errs toward pattern. It finds signal in static. It connects dots that do not need connecting and builds narratives from data that is simply random. Confirmation bias is not a character flaw. It is a factory setting. And it has produced a long, embarrassing, instructive record of scientific conclusions that looked compelling right up until they did not. This is the appropriate context for everything that follows. Not as a reason to dismiss the timing correlations in this story, but as a reason to hold them with the specific kind of discipline that the evidence currently justifies, which is neither dismissal nor certainty, but something more uncomfortable than either. Genuine open-endedness. The kind that does not resolve cleanly and does not offer the satisfaction of a conclusion. With that established, let us talk about the timing. Comet C/2026A1 reaches perihelion on April 4th. 3 days from the moment this anomaly reached its current confirmed global scope, with sightings across 3 continents and a southern hemisphere data point that removed the last geographic escape route from the northern hemisphere narrative. The comet is passing approximately 50,000 kilometers from the solar surface, a category of encounter that solar scientists describe as a sun-grazer or near-sun-grazer approach, language that sounds dramatic because it is. To put 50,000 kilometers in perspective, the Sun's diameter is approximately 1,392,000 kilometers. This comet is passing at a distance from the solar surface that is less than 4% of the Sun's own diameter. It is skimming. And objects that skim the Sun at these distances do not do so without consequence of any kind. At 50,000 kilometers above the solar surface, the gravitational field is intense in ways that have measurable effects on the structure and trajectory of any object passing through it. Tidal forces, the differential gravitational pull across the near and far sides of the object, are significant enough to stress the internal cohesion of a comet nucleus. Solar radiation pressure at that distance is extreme. Outgassing from volatile ices, which drives the spectacular tail structures visible in sun-grazing comets, intensifies dramatically. The object may survive the passage intact. It may shed significant material. It may partially disintegrate, leaving a trail of fragments along its orbital path that will continue to evolve independently for years or decades. What happens at perihelion to a sun-grazer is genuinely uncertain in ways that make prediction difficult even with good observational data. But perihelion is not the most relevant moment for the mechanism we are considering. If a comet's gravitational influence on existing inner solar system material is responsible for any part of the current anomaly, the work was done earlier, on prior passages through the inner solar system, when the comet was moving through the populated regions of the asteroid belt and the inner planet zone, its gravitational field nudging the orbits of nearby small bodies in ways that accumulated slowly and expressed themselves as altered orbital parameters. The fireballs we are seeing now would not be from this perihelion passage. They would be the downstream consequence of orbital evolution set in motion by earlier passages, finally manifesting in Earth-crossing configurations at this particular moment in time. The April 4th perihelion is not the cause. It is potentially the timestamp that tells you when the comet was last in a position to have done the work that produced this. The timing of the perihelion relative to the anomaly peak is a fact. Whether it is a meaningful fact, whether the correlation reflects a causal relationship or is simply two unrelated events sharing a calendar, is genuinely open. Holding that openness without collapsing it into either dismissal or certainty is the scientifically correct position, and it is also the intellectually honest one. Then there is 3I/Atlas, and this is where the story acquires a dimension that has no precedent in the modern history of solar system science. 3I/Atlas was catalogued as an interstellar object, not a body that formed in our solar system and subsequently wandered into unusual orbital territory, but an object that originated in another stellar system entirely and arrived in hours on a hyperbolic trajectory, meaning it was moving too fast to be gravitationally bound to the Sun, meaning it passed through and kept going, meaning it is now somewhere beyond the outer solar system heading back into interstellar space, on a path it will follow indefinitely. It made its closest approach to the Sun in late 2025, approximately 5 months before the current anomaly window, and its trajectory through the inner solar system, when projected geometrically, aligns with the Anthelian region, the exact region of the sky where background fireball activity has doubled to record levels. Before going further, the same epistemic discipline applied to the comet applies here, but more forcefully. The trajectory alignment has not been confirmed as causal by the American Meteor Society or any other scientific body. It is an observational note, a geometric fact about where 3I/Atlas's path through the solar system points when projected onto the sky, and a separate observational fact about where the fireball anomaly is concentrated. Those two facts happen to correspond. That correspondence is real. What it means is not established. The physics of how an interstellar object at hyperbolic velocities would transfer meaningful perturbation energy to the inner solar system's existing small body population is not well modelled. Interstellar objects move fast, faster than bound solar system objects by definition, because they are not bound. The gravitational interaction time between a fast-moving interstellar object and a slow-moving inner belt asteroid is brief. Brief interactions transfer less momentum than extended ones. The perturbation energy available from a close pass by an interstellar object at hyperbolic velocity may be smaller than intuition suggests, and the orbital changes it produces in nearby bodies may be correspondingly subtle. Whether subtle orbital changes accumulated over 5 months can produce an anomaly of the magnitude we're observing is a calculation that has not been done with sufficient precision to generate a confident answer. The 5-month timescale between the interstellar passage and the current anomaly is either an intriguingly short delay for orbital perturbation effects to manifest in observable fireball rates, or an arbitrary number that feels significant because we are looking for connections, and 5 months is recent enough to feel relevant. Both of those interpretations are available. Neither is currently supported by a completed causal chain. But here is the epistemological problem that sits at the centre of this entire discussion, and it is one that applies symmetrically to both the skeptical and the credulous positions. Saying this is probably a coincidence requires a level of certainty about the null hypothesis that the current evidence does not provide. And saying this is probably connected requires a level of certainty about a causal mechanism that the current evidence equally does not provide. The honest position is not confident dismissal. The honest position is not confident connection. The honest position is that the timing correlations exist, they are specific, they are multiple, and they have not been closed in either direction. A comet at perihelion in 3 days, on a sun-grazing approach that represents one of the closest solar passes in the observational record for an object of this size. An interstellar visitor that transited 5 months ago on a trajectory that intersects the exact zone of sky where the anomaly is concentrated. A doubling of the Anthelian background that has no identified cause. A global surge of high energy, high inclination, compositionally unusual objects arriving at rates that exceed any single known explanation. Each of these facts presented individually to a skeptical scientist could be labelled interesting but unconfirmed and set aside without intellectual dishonesty. Presented together, stacked inside the same narrow temporal window, pointing at the same region of sky, accompanying a confirmed anomaly that the relevant scientific institution publicly acknowledged and could not explain, they form a pattern that nobody has explained and nobody has closed. The rigorous response to that pattern is not to declare it meaningful, it is not to declare it noise, it is to continue the investigation with the specific question in mind. Is there a causal mechanism, physically coherent and observationally testable, that connects these timing correlations to the confirmed anomaly? That question has not been answered. The data to answer it may not yet exist. The tests that would generate that data, cosmic ray exposure dating of recovered meteorites, precise orbital reconstruction of the anomaly events, detailed modelling of the comet's prior passage history, are ongoing or not yet begun. The timing may be noise, it may also be the most structurally important feature of this entire story, the thread that, once pulled, unravels a sequence of cause and effect that was operating above our detection threshold for months before the fireballs made it visible. We do not yet have the data to know which. And living in that suspension, between possible meaninglessness and possible significance, between a loud coincidence and the first legible sentence of something much larger, is exactly where this investigation currently sits. That is not a comfortable place, but it is the only honest one. Part 10. The Detection Blind Spot. While all of this was happening, a camera in Ohio was offline. Sit with that for a moment before moving on, because it's the kind of detail that is easy to register as a minor administrative footnote, and then file away while the larger story continues. A camera went offline, things go offline, equipment fails, networks have gaps. This is not unusual in any observational science infrastructure, and it is tempting to treat it as local colour, a small irony in a story already full of larger tensions. It is not local colour. It is a window into a structural problem that sits beneath the entire investigation, and understanding it properly changes how you interpret everything the data is telling us, including the parts that seem most solid. The American Meteor Society's Fireball Observation Network is not what most people probably imagine when they picture a scientific institution monitoring the skies above an entire continent. The mental image that phrase tends to produce is something like a control room, banks of screens, overlapping camera feeds, redundant systems, the kind of infrastructure that implies nothing significant could cross the atmosphere undetected. That image is wrong. The reality is patchwork, a genuinely useful, carefully maintained, continuously improving patchwork built from decades of dedicated effort by scientists and citizen observers working with limited resources but a patchwork nonetheless. Dedicated meteor cameras at fixed observing stations form the professional backbone. Around that backbone sits a much larger informal network. Dashboard cameras mounted in cars, doorbell cameras pointed at residential streets, security systems recording parking lots and building facades, and the smartphones of an increasingly connected civilian population who know, because apps and social media have made it possible, that their sighting report matters and has somewhere to go. Each layer of that system contributes something different and has different limitations. The dedicated professional cameras provide calibrated data, precise timing, quantified brightness, known field of view, consistent sensitivity thresholds. When two or more of them catch the same event from different locations, the geometry of their observations can be combined to reconstruct a three-dimensional trajectory. You get an entry angle, you get a velocity vector, you get, in principle, an orbital path that can be traced back through the solar system to a point of origin. That is the data that answers the hard questions, not just that something fell, but where it came from and what kind of object it was. The Citizen network provides coverage and confirmation. It fills in the gaps between professional stations. It generates the witness counts that flag high significance events and draws attention to things the dedicated cameras might have missed. But a doorbell camera in suburban Columbus and a dash cam in a Cleveland parking garage do not give you orbital mechanics. They give you a bright light in the sky and a timestamp. Ohio matters specifically because of where it sits on the map. The central corridor of North America, Ohio, Indiana, Pennsylvania, Kentucky, Missouri, the populated interior of the eastern and midwestern United States, is a zone where the professional camera network at adequate density would provide overlapping fields of view for events crossing a wide swath of sky. A camera in Ohio is not just covering Ohio, it is providing the triangulation baseline for events that originate or terminate hundreds of miles away. A fireball crossing southern Indiana at 2 a.m. might be recorded by cameras in Tennessee, Michigan, and Ohio simultaneously. And it is the combination of those three viewpoints, the parallax between them, the timing differences in when the object crossed each camera's field, that transforms a visual record into a trajectory calculation. Remove one vertex of that triangle, and the calculation becomes less precise. Remove the Ohio vertex specifically, and you lose the triangulation anchor for a significant portion of the central corridor's sky coverage. During the Anomaly window, the same weeks that produced 1,100 witness events, a 4.5 sigma statistical deviation, the German fireball photograph, and the New Zealand report, the Ohio camera was not providing that data. Events that crossed the central corridor during that period produced witness reports. They produced brightness estimates from civilian observers. They did not produce the calibrated trajectory reconstructions that would have told scientists with precision what orbital paths those objects were on and where in the solar system they originated. The data gap is not catastrophic. Science works with incomplete data all the time. But it is real, and it is located at exactly the geographic position where complete data would have been most valuable during exactly the period when the anomaly was at its most statistically significant. And Ohio was not the only gap, it was simply the most specifically locatable one. The reliance on citizen reports as the primary coverage mechanism for large portions of the observation network introduces a structural bias that is worth understanding clearly, because it shapes the entire data set from which conclusions are being drawn. A 100-witness fireball event, the threshold used to identify the most significant events during this anomaly window, requires 100 people who are simultaneously awake, outdoors, or near a window, looking in approximately the right direction, sober enough and attentive enough to notice something unusual in the sky, and sufficiently motivated and equipped to file a formal report with a tracking organisation. That combination of conditions selects with considerable force for specific kinds of geography: urban environments, suburban environments, wealthy countries with high smartphone penetration, and populations connected to the apps and social networks through which fireball reports travel. The northeastern United States, Western Europe, Australia's populated southeastern coast. It does not select for the Sahara Desert, where the skies are among the darkest and clearest on the planet, and a fireball would be visible for hundreds of miles in every direction, but where the population density is low enough and the reporting infrastructure sparse enough that the same event generating 300 witness reports over Chicago might generate 3 over Mali. It does not select for the southern Pacific Ocean, where there are no cities and no dash cams and no doorbell cameras, only the occasional research vessel or commercial shipping lane with personnel who may or may not be looking up at the right moment, and who almost certainly have no mechanism for filing a formal AMS report from the middle of open water. It does not select for northern Canada or the interior of Siberia or the vast stretches of central Australia between the populated coasts. The majority of Earth's surface, measured in square kilometres rather than in people, is functionally invisible to the current observation network. This is not a criticism of the network or the people who built and maintain it. Building global atmospheric observation infrastructure is genuinely hard, genuinely expensive, and genuinely dependent on the kind of sustained institutional support that scientific programs rarely receive at the scale the problem requires. The AMS is doing exceptional work with the resources available to it. The citizen science community that supplements the professional network has contributed meaningfully to fireball science in ways that would not have been possible a generation ago. The data that identified the 4.5 sigma anomaly, that tracked the progression from 6 events in 8 days to 1,100 witness events in a single month, that flagged the Brandenburg photograph and received the New Zealand report. All of that came from a system that, despite its limitations, was functional enough to detect something real and significant. But functional enough to detect is not the same as comprehensive enough to fully characterize. The events we know about are the events that happened across the sky over cities and towns and highways, where someone was watching and something was recording. They are the visible fraction of a larger population. The 4.5 sigma deviation, the doubled anthelion background, the 11 high witness events. These numbers describe what intersected our observational capacity during this window. They are a lower bound on the actual activity level, not a complete count. The true number of significant fireball events during this period, accounting for the events that crossed the southern Pacific unobserved, the events that lit up the Saharan night with nobody watching, the events that blazed over the Siberian interior and left no record anywhere, is larger than what the data shows. By how much we cannot say. The network is not built to answer that question. What this means for the central investigation is uncomfortable but important. We are reconstructing a system-level change in near-Earth space through instruments that cover perhaps 40% of the planet's sky with any real density, with known gaps at critical geographic locations, relying on civilian reports that are structurally biased toward wealthy, connected urban environments. The conclusions drawn from that data are real. The anomaly is real. The sigma deviation is real. The global spread is real. But they are real conclusions drawn from an incomplete picture, and the incompleteness runs in one direction, toward undercount. If anything is being missed, it is more events, not fewer. If the coverage gaps are biasing the data, they are biasing it toward making the anomaly look smaller than it is, not larger. The camera in Ohio was offline, and the part of the sky it was watching went unrecorded during one of the most statistically anomalous fireball periods in the modern observational record. We are describing a system we barely observe, and what we can see is already strange enough that the parts we cannot see may be stranger still. The known data is the floor of this story, not the ceiling, and the ceiling, whatever it actually is, has not been measured. Part 11. The competing explanations ranked but not equal. When the full dataset is on the table, all of it, assembled in one place rather than examined piece by piece, something becomes clear that is easy to miss when you are moving through the story sequentially. The anomaly is not one thing. It is several things happening simultaneously, each of which would be notable in isolation, and all of which are happening together in ways that strain the explanatory capacity of any single framework. The sigma deviation, the global spread across 3 continents and 2 hemispheres, the HED meteorite falls and their impossible angular separation, the high inclination objects arriving at twice their historical rate, the anthelion doubling sustained across weeks, the sonic boom rate at 79%, the southern hemisphere data point that removed the last geographic escape route. Put all of that on the table at once, and 5 broad categories of explanation present themselves. They are not equally supported by the evidence. They are not equally capable of surviving contact with the full dataset, and none of them, individually, survives that contact completely intact. The weakest explanation, the one that requires the least imagination to construct, and the most imagination to defend once the numbers are examined, is pure statistical anomaly. Random fluctuation. The idea that nothing unusual is happening in the near-Earth meteoroid environment, that the clustering of extreme events during this window is simply an improbable run, the kind of streak that any sufficiently long random process will eventually produce given enough time and enough opportunities. This explanation deserves honest engagement rather than dismissal, because it has genuine academic standing. Random processes do produce rare clusters. The law of truly large numbers is real and has genuine force. Given a large enough universe, operating over a long enough timeline, extraordinarily improbable things will happen, and they will happen to someone, somewhere, at some point. The question is whether the someone somewhere sometime framework applies here. It does not survive the number. 4.5 sigma is not in the territory of improbable things that happen occasionally to someone. It is in the territory of improbable things that happen, statistically, perhaps once across the entire span of recorded human history, if the baseline model of the fireball population is correctly specified and the anomaly is purely random noise. That is the threshold, one occurrence across all of human civilization, and that calculation applies to the sigma deviation alone, before you layer in the global spread, before you account for the anthelian doubling, before you notice the HE decompositional anomaly, before you factor in the high inclination doubling. Each of those additional features requires its own improbability budget. The combined probability of all of them occurring simultaneously by pure chance is not meaningfully different from zero. Pure statistical fluctuation remains technically on the table, in the same way that any hypothesis remains technically on the table until it is formally falsified, but its explanatory power is exhausted well before it reaches the second line of the dataset, let alone the full picture. The second explanation is considerably more viable, and it is the one that fits the largest number of individual data points without requiring exotic assumptions. An unknown debris population. The idea that a diffuse, previously uncharacterized population of meteoroids with unusual orbital properties exists somewhere in the inner solar system and has been intersecting Earth's path at elevated rates during this window, a population that was simply too sparse or too poorly positioned to have generated anomalous signals in prior years, and which the current geometry of Earth's orbit has brought into more frequent contact. This explanation fits the anthelion amplification naturally and elegantly. If the source is genuinely diffuse, spread across a range of orbital paths rather than concentrated in a coherent stream, then the anthelion zone is precisely where you would expect to see the signal expressed most strongly, because the anthelion source is by definition the region where diffuse background material tends to concentrate in terms of its intersection geometry with Earth's orbit. A diffuse population would show up there first. It also fits the absence of a coherent radiant, because a population distributed across a range of inclinations and eccentricities would not produce a single point source signature in the sky. The meteors would appear to come from a broad zone rather than a specific direction, which is consistent with what the data shows. And it fits the global distribution, because material spread across a sufficiently wide range of inclinations could intercept Earth from multiple directions simultaneously, explaining why the anomaly expressed itself across hemispheres without the temporal structure you would expect from a directional stream. Where the unknown debris population explanation struggles is with the HED falls, a generic diffuse population of inner solar system material, the kind that accumulates over billions of years of gravitational scattering and orbital evolution, does not obviously produce an elevated rate of Vesta family chondrite meteorites in a single month. HED material is compositionally specific. It comes from a differentiated body. Finding two examples of it in rapid succession, with an angular separation of 98 degrees, requires either extraordinary coincidence within a generic diffuse population, or a more specific origin story in which Vesta family material is disproportionately represented in whatever is currently arriving. The diffuse population hypothesis needs an amendment to account for that specificity, and the amendment it needs sounds a lot like the third explanation. Parent body disruption addresses the compositional specificity directly and cleanly. If a single large asteroid, or a cluster of related bodies sharing a common gravitational heritage, experienced a significant fragmentation event at some point in the geologically recent past, the resulting debris field would carry the compositional signature of its parent. If that parent was a differentiated body, a Vesta family member with a mantle and a crust, and an internal structure shaped by a magma ocean, then the fragments would include diogenites, eucrites, howardites, exactly the HED material that has been falling during this anomaly window. Parent body disruption would explain why the compositional profile of the arriving material is anomalous. It would explain why rare meteorite types are appearing at elevated rates. It would explain the high inclination objects if the fragmentation event was energetic enough to scatter debris across a range of orbital inclinations rather than confining it to the ecliptic plane. And it would explain the temporal clustering of rare falls, not as coincidence, but as the expression of a shared origin event whose debris is arriving in a concentrated window, because orbital evolution has brought multiple fragments to Earth-crossing configuration at the same time. Where parent body disruption struggles is with the global distribution and the anthelian doubling. A fragmentation event produces a debris field that, in its early stages, retains some directional coherence. The fragments spread along the parent body's orbital path, but they do not immediately distribute themselves isotropically around the entire inner solar system. A fresh fragmentation would tend to produce a more directional signal, at least initially, with events concentrated in a narrower band of sky, corresponding to the parent's orbital corridor. The anthelian doubling is not directional. The global spread across 3 continents and 2 hemispheres is not directional. Explaining those features from a single recent fragmentation event requires that the event happened long enough ago that orbital evolution has had time to disperse the fragments widely, which raises the question of why the arrival rate is spiking now rather than having been elevated for the years of dispersal that would have been required. The fourth explanation, gravitational perturbation by an external agent, is the most intellectually uncomfortable, not because it is physically implausible, but because it requires identifying something, a name, an object, a specific gravitational actor massive enough and proximate enough to have altered the orbital distribution of existing inner solar system material on a timescale consistent with the current anomaly. This explanation naturally produces a diffuse non-directional signal, because a gravitational actor does not move material from point A to point B along a single path. It changes the orbital parameters of material already distributed across many locations simultaneously, nudging a fraction of each population slightly, changing perihelion distances, altering inclinations at the margins, pushing objects that were just outside Earth-crossing geometry into configurations that now intersect. The result is elevated activity from multiple directions at once, with no single radiant, no coherent stream, no directional structure. That is a precise description of what the data shows. Where gravitational perturbation struggles is with time. Orbital mechanics perturbation effects typically operate over long periods, years to decades, for subtle changes to accumulate into observable reconfigurations of significant populations. Getting from a perturbation event to a measurable anomaly in 5 months is at the fast end of what the physics comfortably predicts. Not impossible, specific orbital geometries can produce faster responses, particularly for objects already near the boundary of Earth-crossing configurations that require only small nudges, but fast enough that the timescale requires justification rather than assumption. The fifth possibility is not a single explanation. It is the acknowledgement that complex systems rarely change state for single reasons. A background population amplified by perturbation, interacting with the fresh debris of a recent disruption event, expressed against a system already sensitized by the passage of an unusually massive or unusually close object. 3 partial causes combining to cross a threshold that none of them would have crossed alone. Multi-mechanism causation is not exotic. It is, in complex dynamical systems, the norm rather than the exception. Every explanation works until you apply it to the full dataset, and no single explanation yet survives that application completely. The honest position is not that the answer is unknown. It is that the answer, whatever it turns out to be, is going to be more complicated than any single sentence can contain, and the investigation is not finished. Part 12. The real question. Strip away the sigma values and the orbital mechanics and the compositional mineralogy for a moment, and look at what this story actually is. Not what it contains, not the technical apparatus of it, the witness thresholds and the declination angles and the achondrite classifications and the perihelion distances. Those things matter, and we have spent considerable time on them for good reason. But underneath all of that technical scaffolding, when you remove it piece by piece and look at the bare structure of what has happened, the story is simpler and stranger than any of its components individually suggest. Something changed. It changed in a way that was measurable, confirmed publicly, by a major scientific institution after a rigorous process of eliminating alternatives. It changed globally, expressing itself across at least 3 continents and both hemispheres within a narrow calendar window that no geographic or observational explanation has survived. It changed in ways that produced physical effects that exist independently of any database or reporting network. Meteorites on the ground that people picked up with their hands, sonic booms that rattled windows in populated areas, fireballs bright enough to photograph from residential neighbourhoods in central Germany on an ordinary night. And it changed in a way that has not reversed, has not stabilised, and has not been explained. That is the story. Not the individual fireballs, each of which could theoretically be filed away as an unusual but isolated event. Not the sigma number, which is striking but abstract. Not the German photograph or the New Zealand report or the Anthelian doubling taken individually. The story is the conjunction, the fact that all of these things happen together inside the same narrow window and that the window has not closed. The fact that the confirmation happened, that the AMS applied rigour, eliminated the obvious explanations one by one, and said publicly that something has changed, and the anomaly responded to that confirmation not by contracting, not by normalising under scrutiny, but by expanding, by crossing into Europe, by appearing in the southern hemisphere, by revealing itself as a global phenomenon at precisely the moment when science had just finished confirming it as a real one. That sequence matters. Detection came first, a cluster of events in the United States striking enough in quantity and character to trigger serious scrutiny rather than routine logging. Confirmation came next, with the AMS statement on March 25th that eliminated every obvious alternative and left the field clear for the acknowledgement that something genuine and unidentified had changed. Then came escalation, not of the events, which had been escalating already, but of the scope. The story moved from American anomaly to global phenomenon in a matter of days. Germany, New Zealand, the Anthelian doubling revealed as sustained and record level. The progression was clean enough to trace in hindsight, and troubling enough that the trace raises questions about what comes next in the sequence. What has not come yet is explanation, and the absence of explanation at this particular moment in the investigation is not a temporary gap that patients will automatically fill. It is a reflection of where the science actually is, which is earlier in the process than the confidence of some of the public discussion might suggest. We are not in the phase where competing models are being refined and the scientific community is converging toward consensus. We are in the phase where the observations are still outrunning the frameworks, the data is still being collected, the events are still happening. The comet reaches perihelion in 3 days, and whatever that passage contributes to the picture has not yet fully expressed itself. The recovered meteorites sitting in laboratories have not yet had their cosmic ray exposure ages measured, the clock that would tell us when they were separated from their parent bodies and whether that separation was recent enough to be relevant. The full trajectory reconstruction for the anomaly window is not complete. The southern hemisphere data gap is still a data gap, still covering the majority of a hemisphere with sparse instruments pointed at a sky that may be telling a story we are not equipped to hear. We are at the moment in an investigation when the witnesses have been interviewed and their accounts recorded, but the forensic results are not back yet. The physical evidence is in the laboratory. The orbital calculations are being run. The hypotheses are on the whiteboard. The conclusion is not. What does that mean for anyone trying to understand what is happening above them right now, tonight, while this remains unresolved? It means living with a specific kind of uncertainty that is unusual even by the standards of scientific inquiry, where uncertainty is nominally the default state. Most scientific uncertainty is the uncertainty of refinement. You know roughly what is happening. You're working out the precise parameters. The answer is bounded even if not yet exact. This uncertainty is different. It is the uncertainty of an open question at the fundamental level. Not how big is the anomaly, but what caused it. Not how long will it last, but whether it represents a temporary fluctuation or the beginning of a sustained change. Not which model best fits the data, but whether any existing model was built to fit data like this at all. The near-Earth meteoroid environment is not an abstraction. It is easy to treat it as a technical domain belonging to specialists, populated by objects too small to see and too rare to worry about on any given day, relevant to planetary scientists but not to anyone else. That framing is comfortable and mostly harmless in normal times. These are not quite normal times. The near-Earth meteoroid environment is the physical medium through which Earth moves every second of its orbital journey. It is the debris field in which this planet is a traveller, and the character of that debris field determines real things. The statistical frequency of atmospheric encounters large enough to produce light shows visible across entire countries, the probability of bolide events energetic enough to generate pressure waves that reach the ground, the background rate at which rocky material survives atmospheric entry and lands somewhere as a recoverable meteorite. The character of that environment sets the parameters of the sky above you in ways that are usually invisible because they are usually stable. If the character has changed, if what we are observing is a genuine baseline shift rather than a temporary spike, then the parameters have changed, not dramatically, not in the direction of imminent catastrophe or extinction level risk, which is a framing that would require evidence far beyond what currently exists, and that is not what this story is claiming. But changed in the statistical sense, in the way that a modestly elevated background rate of large atmospheric events would express itself over years and decades, more frequent bolide events over populated areas, a modestly elevated probability of ground-reaching falls, a sky that is, by a small but real and measurable amount, more active than it was during the entire modern era of systematic observation. The kind of change that would not be alarming in any single month but would be clearly visible when you looked back at the data across a decade. A temporary fluctuation leads somewhere different. The Anthelion background returns to historical norms. The high inclination object rate drops back to its baseline. The next month looks like normal months have looked for the 30 years of systematic observation that preceded this one. The anomaly becomes a case study in the dramatic variability of a complex system, written up in a journal, cited as an example of how the near-Earth environment can produce statistically extreme windows without any single identifiable cause and filed away as resolved. That outcome is possible. It may even be the more likely outcome in a strict probabilistic sense, if only because temporary fluctuations are more common than permanent baseline shifts in most dynamical systems. But we do not know which outcome we are in. The data is not yet sufficient to distinguish a months-long fluctuation from the leading edge of something sustained. The observation window is too short, the forensic data is too incomplete. The theoretical frameworks for what a sustained baseline shift would look like in its early stages are not developed well enough to generate a confident prediction. Nobody is in a position to tell you with certainty which future you are moving toward, because the honest answer is that nobody knows. And the honest answer deserves to be said plainly rather than softened into the kind of cautious non-statement that sometimes substitutes for genuine scientific humility. What exists right now, confirmed and documented and physically real, is a changed environment, a global expression of that change, an unresolved cause, and a set of temporal and geometric correlations specific enough and numerous enough that neither connecting them nor dismissing them can be done without making assumptions that the current evidence does not support. We have been watching a system we thought we understood produce results that do not fit our understanding. We have been doing it for weeks, across 3 continents, in both hemispheres, at a statistical level that the relevant scientific institution confirmed and could not explain. And the anomaly has not closed. For the first time in years, we are not watching a known system behave strangely. We are watching a system we do not fully understand begin to reveal itself, and what it is showing us, in the data from Ohio and Germany and New Zealand and the doubled Anthelion background and the HED meteorites and the high inclination arrivals and the 79% sonic boom rate, is that the sky above us is not as quiet, not as predictable, and not as thoroughly mapped as the modern era of planetary science had led us to believe. The line that was crossed was not just geographic. It was the line between a local curiosity and a global unknown. And unknown systems, when they begin showing you their edges, rarely stop at the first reveal. The question is not what the last fireball meant. The question is what comes next. And right now, for the first time in a long time, the honest answer to that question is, we are watching to find out.